Function notation. So function notation is nothing to do with domain and range. It's just another review that's really important for grade 12 pre-cal. So functional notation is basically a fancy term for writing y is equal to. So in a lot of stuff in grade 9 through 11, we had y was equal to mx plus b. And then in grade 11, we looked at y equals x squared. Okay, we had vertex form, we had standard form, we had a lot of stuff last year that was mostly y is equal to. But in grade 12, we might be dealing with multiple graphs at once. That's when function notation comes in handy. So a linear function, like I said, is y equals mx plus b. You can have an example like that. What if we had the same function but in function notation? Well, you just write it exactly the same way. You go f bracket x bracket equals 3x plus 2. You've seen it a million times, but it is something that we're going to use a lot of this year. Remember that you say it like this, f of x, not f times x. That's a dot there for multiplication. So it's not f bracket x like a multiplication. It's actually a notation f of x. This really comes in handy when we have multiple functions going on at once. So let's say we had two graphs like this where f of x equaled this and g of x equaled this. So that's when function notation really comes in handy. All right, so to finish this booklet off, we just have some examples. What you do with function notation is you are going to input numbers into the x spot. And what that's going to do is it's going to tell you if I put f of the number 3, then that is asking me x is equal to 3, what is y equal to? So it's a basic substitution. If I go f of 3, I plug that into x, and then I solve for y. F of x and g of x and h of x and all those things are replacing y. So you'll give an x value, solve for the y value. Okay, so f of x is equal to 2x plus 3, so all of this is just basic substitution. F of negative 1, I plug in negative 1, and that tells me that y is equal to 1 when x is equal to negative 1. That's what this point means. So x is negative 1, y is 1 on the graph. Same thing at 4, basic math there. Then we get into some variables, but it's really the same thing. I can plug in negative 2n, which is 2 times negative 2n, but I can't combine those. They're not like terms. It just could mean a different function is possible now. Same thing with d. If I plug in x minus 4, now it's a binomial. Multiply the 2 through, and you end up with 2x minus 5. Just watch your like terms and those types of things. Pause the video, guys, if you need to at that point. If we have f of x is given as this, there's the graph. It's drawn for you. You don't have to draw it yourself. They want you to find these points. So I could plug it in fully. All right, so I plug it in. I get 1 as an example. F of 1 is 1 squared minus 2 times 1 minus 1. Watch your brackets. If you're squaring a negative, those types of things, be careful. You get negative 2. We'll take a look back up top. F of 1 is x. You end up at negative 2, just like it is below, right? So 1, negative 2 is on the graph, but it's also found algebraically. Okay, so these questions are just proving to you that it's the same on the graph as it is algebraically. So this is, you can just find it on the graph or you can plug it in. That's why there's really no work shown on this one. Okay, you'll notice that for f of x equal to 2 or f of x equal to negative 2, that now you don't have a value for x. This is actually saying y equals, right? Because remember that f of x replaces y. So when y is equal to negative 2, we found it to equal 1 for x. And then when f of x equals 2, x equals negative 1, but it also equals 3. Remember that on parabolas, we often have 2 points at the same y value. The only reason we didn't here is because that was a minimum point or the vertex. Okay, rewrite these in function notation. Usually we just go f of, it can be f of, g of, h of, it doesn't matter, but it depends on your variable. So this would be f of x equals, because there's an x value on the right. This can be f or h or whatever, but it has to be of p because p is the variable on the right side. Okay, same thing, plug in basic substitution, same as above. So this is domain and range as along with functional notation. So domain and range should be fairly fresh in your memory. So we'll go fairly quickly here. So an example like this, just a reminder that domain is all your x values and range is all your y values. Try to treat them as two separate questions. So domain, we're gonna go left to right. Range, we're gonna go bottom to top. So domain, -6 to 3, range, -5 to 8. This top line here is what we call interval notation. So round bracket to square bracket. The one below it is set notation, which is usually some number less than x, less than another number. Sometimes it might just be greater than or less than only, and sometimes it's all of the real numbers. So we'll get to those kind of examples. And then range, same idea, interval and set notation. So you guys can try example 1A on your own. Okay, so go left to right. Remember, an open dot means open bracket or not equal to. And then for range, go bottom to top. For a lot of this video, guys, I'm going to go pretty quick. So just please pause the video when you need to and rewind if I'm skipping over a question, which I will often do. Question B. So this is a parabola. All right, from last year, did a lot of these guys, right? Just a reminder, going left to right for domain would be the infinities. So that's going to look like this, negative infinity to positive infinity with some round brackets. But then it will also have this fancy guy here for set notation. X such that, okay, so the X line like we had in the last one, X is an element of the real numbers. Fancy way of saying that X can be absolutely any number on the graph, but we did that a lot in grade 11. And then for the range, we go from negative infinity at the bottom up to 8. Okay, remember that if it's a line, we're going to include it. So that means a square bracket, negative infinity up to 8. And then we'll just say that y is less than or equal to 8. Okay, so no infinities in set notation, just y is less than or equal to 8. This may pop up as well when you have breaks in your graph. Okay, so negative 9 to negative 8. There's a break in x from left to right. There is no x value between negative 8 and negative 2. So we just put the letter capital U, and then we go from negative 2 to 8. In set notation, we often either put a comma or just the word or. Same thing happens in the range. There's a little break in between there. You're going to see a lot of graphs like this year where it's just kind of random lines going on. Try not to get thrown off by it. If they're all connected by lines, you should just be able to find your lowest value to your highest value. And sometimes, like in question C, there might be a break and you put the letter U or put the word or. So in this case, left to right, we go negative 6. Yeah, you got to dip down and up and whatever. But from negative 6, it stops at 6 from left to right. So that's our domain. And then range, we go from negative 4 up to 4. I don't see any breaks happening in that case. Straight lines, infinities for both. This is what we call a reciprocal function. We briefly did this in grade 11 as well. Okay, a rational or a reciprocal function. You go from negative infinity up to 0. You'll notice that it stops and starts again. That's because this is what's called an asymptote. Okay, we did asymptotes in grade 11. All right, that's where it stops. So at 0, it's not included, but then it starts again at 0. It's a really weird concept where it gets really close to it, but it stops. So that's why it has 0, round bracket, union, 0 again, and then keep going to infinity. You'll notice it's the same in the y direction as well because it also stops at 0 at the x-axis there. In set notation, we write it a little differently. We say that x and y can be anything except they cannot equal 0. So it's kind of a shortcut to say x and y can be anything except we just say that x cannot equal 0. This one has an overlap in the y direction. Just be careful with that. I'll leave you guys to that one on your own. Okay, so that's domain and range. Pause the video if you need to, go back, make sure all the notes are filled in.